Okay, so good everybody. So we want to go through some fundamentals or do like a recap. I think then tomorrow we can start our class proper. Okay, so before now, for instance, if somebody says he's a data analyst, it then means that the person understands a few things. The person understands I'm trying to start my Anaconda. That's why you're having all of these prompts. So that means the person understands the data analysis life cycle. So anytime we talk about the data analysis life cycle, what are we trying to say? We're trying to say the person understands definition of objectives. The person understands data collection. And of course, before you can do data collection, you want to have some questionnaire. You want to have an idea about what you want to collect, and you must be able to standardize whatever data that you collect. Then you want to do
Hello, Mr. Victor. Can you hear me?
Okay, sorry, I was muted. So can you hear me now?
Okay.
Okay, so we talked about data analysis life cycle there, which involves first, the person must understand objectives definition. You must first define your objectives, why you want to do the analysis. Then the next thing is that you want to actually collect data. Then the next thing you want to do is to analyze data. Then, of course, you do interpretation. Then you do presentation. So at times you can have in between data collection, you can have data cleaning, you can have data transformation, like to convert data from one form to the other. Let's say you want to do BMI index, for instance. And for you to do this, you need to get their kg and get their height. That's their weight and their height. So to do this, at times, if you collected your weight in pounds, if you're in Nigeria or in some countries, you might need to take this back to kg. If you collected height in meter and you want to work on with feet, you might need to convert it to feet, or if you collected in centimeter, you might want to convert back to meter. So this is what you call data transformation. Or let's say somebody said he spent 10,000 naira per week on TP. So that's data you collected. Data transformation means that when you're trying to use data, if your goal was per day, that means if the work week was Monday to Friday, it then means you would divide this by 5. So if this is TP and you have 10,000 collected, so you now have daily TP. So this is the data you're actually looking at for. So you will now say this column, that is TP divided by 5. So you now get this particular data. So that's what you call data transformation. So in trying to collect data, you might do all of this. In analysis, this is where we are now very, very much concerned about. Because in analysis, you're going to use different tools. So far, we've learned some basics of Excel, some basics of SQL, some basics of Tableau. Now, we want to add another tool, Python. And because we don't always, or we don't want to stop at just analysis and interpretation, we want to go to another level called machine learning. That's why we're also learning Python, because Python gives us ability to be able to do more. compared to what we will actually do if we were just using tools like Excel, SQL, Tableau, Power BI, and the rest. So we have a little bit more power when we're using Python. So normally for a data analyst, every data analyst, of course, everybody here, I can categorize everybody here as a data analyst. You could use Excel to do some kind of charts, some bar charts, some graphs, some dashboard. You could use SQL to like query a simple data to like know maybe sum, median, to get things like summary of your data. You can use Tableau. Most of us here have the Tableau dashboard where we did where we have some data set. And for most of us that went through the Cisco data essentials, data analysis essentials, most of us have the Cisco CERT and the Cisco badge. So here we want to talk about Python. So for us to talk about Python, there are a few things I want to clear. The first thing is that you want to understand maybe why am I using Python and how does Python differ from the other softwares? So this is where, aside just data analysis, where machine learning and AI. Okay, let me just ask a question. Who can tell me what is AI? Then if you answer, I have another question for you. What's AI?
AI refers to artificial intelligence.
Okay, good. So AI is artificial intelligence. So what's artificial intelligence? So what is artificial intelligence? Who can try? Victor, artificial intelligence. Victor, I'm listening. What's artificial intelligence? So now let me help you. You know, at the level of data analysis, what you're trying to do is that you're trying to do a lot of exploratory data analysis. And what do you call exploratory data analysis? You are saying, for instance, you have a list of patients for a hospital. Let's say for a healthcare center. Now, we have men, we have women, we have kids, and maybe we'll have neonatal. That is like pre-delivery or those kids that they deliver preterm. Now, if we have 50 men, 200 women, 500 kids, and let's say 30 neonatal patients admitted into a hospital, let's say a healthcare center. Now, at data analysis, what we're concerned about is, for exploratory data analysis, we're talking about the measure of central tendencies. All those things you learned in mathematics, and you were telling the teacher that, please just do what you're doing and leave the class. I'm not going to use this thing again. Just to let us pass the exam and let us be done. So you have it now. So things like mean, things like mode, things like frequency, right? Things like sum or total, things like average. All these measures will help you understand these data you collected. Then you now go forward to now start doing some charts, like bar charts, like histogram. Sorry. You now do something like a bar chart, right? You do something like a scatter diagram. So all of this is just for you to do what? For you to explore the data, for you to understand the data. Things like if you know how many women came to the hospital, If you look at how many kids came to the hospital, how many kids came to the hospital on Monday, between Monday to Friday, or January to December, can we see the distribution? You plot it, you see something like this. Oh, you now say, okay, this is January, this is February, this is March, this is April. As the month goes by, we have more patients coming, or we have more patients during the rainy season or compared to the dry season and all of that. That's what you do our data analysis. The data analysis is just trying to understand data, trying to explore, so that we can actually know what is happening. At times we call it intelligence, data intelligence. And if it's applied to business, we call it business intelligence. So you cannot do business intelligence without exploring your data. Now, at the level of machine learning, what you're trying to do is that you're trying to look out for this data. Do you have things like patterns? Do you have things like trends? Do you have things like relationship between your variables? We know what a variable is. A variable is just a placeholder for data. Things like your men, women, kids, or if it's football now, how many goals was scored, at what minutes was the goal scored. All of those things that hold your data, you call them variable because they change depending on what point in time the data is explored. So at machine learning, you try to look at this data that you have. Do you have some kind of patterns? Do you have some kind of trends? Do you have some kind of relationship between the columns you have in your data? So at machine learning, you're trying to see if there's possibility that, for instance, men between the age of 35 to like 50 have a particular kind of disease. So the only way you can do machine learning is if you now do data analysis, because you must do data analytics first, or you must analyze data first before you start talking about machine learning. So in machine learning, what you're not trying to do is you're trying to now look at your entire data and see if that you can tell another point in your data based on the data that you have. So I normally give students this scenario. I normally say things like, okay, if I took a cup of tea, right? If I took a cup of tea, let's say on Monday, I have a cup of tea. Let's say on Monday, I just have 1 cup of tea. On Tuesday, I have 2 cups of tea. On Wednesday, I have 3 cups of tea. On Thursday, I have 4 cups of tea. On Friday, I have 5 cups of tea. On Saturday, I have 6 cups of tea. Who can tell me how many cups of tea I'm going to have on Sunday? Daniel, how many cups of tea will I have on Sunday?
On Sunday should be 7 on Syria.
Mr. Abubakar, what Mr. Daniel said, is it correct or is wrong?
Yes, I will agree with him.
Why? Okay.
It's on incremental basis.
Yes, if you agree now, how many cups of tea will it take the next Monday?
That's another learning.
So you now see that to do machine learning, you must have sufficient data to establish pattern, trends, relationship. Take for instance, if you check Nigerian population over, let's say, Nigerian population, just go to Google now and say Nigerian population. You're going to find out that our population is in this order. So there's already a pattern over a sufficient period of time. So what can happen now is that we can use different machine learning algorithms to now say, okay, we can forecast. We can tell where this data is going to go. We can forecast. We can say where this data is going to go, right? So that's where machine learning comes in. So at machine learning, the machine here is actually this data, this whole data. We want to check and see if there's a pattern, if there's a trend, then we want to be able to forecast. So we can say, okay, by 2030, Nigerian population is going to be at so. So there are some algorithms that we can use for quantitative data. There are some algorithms we can use for qualitative data. Things like population is quantitative. Things like intelligence. Intelligence at times can be categorized as intelligence quotient, can be categorized as quantitative. Things like, let's say, men, women, with respect to maybe the houses they are going to live. Maybe is it going to be 1 bedroom, or is it going to be 2 bedroom? Is it going to be 3 bedroom? Or your income range, and your gender, or your salary grade, and if you are going to be whether you're going to be promoted or not, or your performance at work, and whether you're going to be promoted to a different cadre or not. So those things that are mixed between quantitative and qualitative, there are different machine learning algorithms we are going to use to be able to do some forecast. So once your data analysis have to do with telling tomorrow, telling the future, that's where machine learning comes in. And this machine, for instance, is actually your data. You're trying to say, okay, you want to train your data so that you understand its trends and patterns, and so that you can tell tomorrow. So this is a little bit higher in terms of knowledge required compared to where you just collect the data and you just plot the graphs. Now, I'm going to differentiate machine learning and AI. At the level of machine learning, you're trying to understand your data and tell how you can forecast the future. Of course, you're going to do that manually. You're going to use some algorithms, like we're going to be learning, let's say, linear regression. We're going to be using some algorithms in Python, like linear regression. We have logistics regression. We have k-means. We have several other algorithms. So we'll just pick 1, 2, or 3 algorithms, and we're going to learn how we can use algorithms to like make some kind of forecast on our data. That's machine learning. Then for artificial intelligence, you're no longer just trying to use a script or some lines of code. What you're trying to do now, you're trying to say, okay, can I automate it? Can I automate the entire process? Things like Google Map, things like Alexa, things like robots trying to maybe do harvest, things like robots trying to make cars, things like ChatGPT that is AI driven that have to collect your data. So you don't have to manually try to say, I want to forecast, or I want to say something. It's already trained. It already understands data. It has, based on several machine algorithms. At AI level, you can now build solutions, hardware solutions, software solutions, and you just need to input data into the stuff or tell it what you need, and it's going to give you a reply. Like you tell the robot, okay, I want to play me Westlife, or play me R&B, or play me, let's say, what's it called? Any kind of song that you want. It's going to play that song for you. It already have the data. It's already trained using different machine algorithms to be able to detect what the input is going to be, and it's going to help you work. So at the level of data analytics, we just do exploratory data analysis. At the level of machine learning, we're trying to do forecasting. We want to tell the future, right? Based on some scripts and some code. At the level of AI, we are automating, right? We can apply it to different industries, things like healthcare, things like research, things like academics, things like robotics. This in this level now, it's still based on data, right? But the thing now is that we don't need any intervention from our end. Who have a question? With respect to understanding data analytics, machine learning, and AI.
So I have small question.
Yes, even if you have a big question, no problem, ask it.
Okay, this machine learning,
Yes.
if you are to make use of it,
Yeah.
it then means you must have the idea of data analysis.
Good. So you can't just start doing machine learning without understanding data itself. Because for every machine learning you want to do, you have to first explore the data. And it's only when you see patterns, trends, relationship, and all of that, correlations, that's where you can now establish and say, okay, there's a relationship between your age and how much you have in your bank account. That's a relationship. Then in machine learning, we can now say, okay, which algorithm, which formula, kind of, so to say, can we use to be able to forecast somebody's bank account balance if we know his age?
Okay.
Working in this particular.
Okay, then on the. Okay, thank you, sir. Then on the AI.
Okay, let me
I
just continue before you ask a question. Then this example I give now, in AI, what we're going to do now, we're going to now build a software or a hardware or a solution that we just need to enter your age or your salary grade in that company. It just tells us how much probably that you can earn. So it makes it very, very, the intelligence is no longer human driven. It's now artificial. It's now data driven. It's not based on what we know or whatever. It's already informed based on the data that it has. Yes, ask your question.
Okay, sir. I used to hear some people organizing training on AI and other things, how to use some software and apps.
Yeah.
Now, without the background of data analysis and machine learning, can you just go single on AI and can succeed?
Yes, that
in the
is
learning?
only if the training you are referring to is just the product of AI. Things like learning how to use AI to create images, learning how to use AI to create music, learning how to use AI to do research and write-ups and pick up data, learning how to use AI to like write research work, learning how to use AI to like build websites. Even these days now, for some of our trainings now, most of them are AI driven. From next year, almost all our trainings are going to be AI powered. Now, you can tap from AI because that is already done. But for somebody that wants to create solutions, you cannot if you don't understand data analysis and machine learning. Because at this point, you're trying to create a solution, trying to create something. Now, I'm not talking about someone that wants to use. If it's to use AI solutions, of course, you don't need to go through learning how to do charts, how to know machine learning algorithms, how to use Python. You don't need all of that. For instance, you just go buy your home automation kit. They install it for you. You say, okay, Alexa, please switch on the AC for me. You are using. Or you just get the software and say, okay, please create an image for me that depicts Bush or Trump trying to shoot a gun. It's going to do it for you, right? So at that point, you are just using. You are not creating. But if you want to create solutions, then you have to go through the process. There's no hack to it. So most of those trainings are geared towards utilization, not actually developing. If I say, okay, develop an AI solution to help inform customers. Of course, we have fuel scarcity today. As I was coming back home, I had issue getting fuel. So we can say, okay, create an AI solution that's going to help inform customers, or create an AI solution that's going to solve fuel issues, queues, so that people, when they get out of their house, they can know where the nearest station where they can have fuel. Now, you see, this solution, the solution is not out there, or it's not out there in this format that you want it. So to do this, it starts from you first, understanding what your objectives are, knowing the kind of data you're going to collect, knowing the stakeholders that are going to be involved, of course, collecting the data, trying to see the relationship between all different fuel stations and stakeholders and wherever, see how to, what kind of machine algorithms you're going to be able to tell, to be able to detect how, when somebody inserts maybe his location, which nearest fuel station is going to be available wherever, how the fuel stations are going to be imputing data into it to be able to predict their fuel availability and all of that. So you cannot create this kind of solution now without a robust understanding of data analysis, machine learning, and of course, different algorithms to be able to set up that kind of thing. But if it's just to use AI tools like ChatGPT, Gemini, and all of those kind of stuff, you don't need any foundation. Who else have a question?
It's clear, sir. Thank you.
Okay, so let's understand what we're trying to learn Python. So I'm just going to give like an overview of what we're going to be learning. Then I'll call it a day. So from tomorrow we will actually start. Then I will this is my Anaconda Navigator, right? So once you're on this software, you start it up. You have several tools here within your environment. You could just come here and tap on the Jupyter Notebook. Because what we're going to be using to code in Python is going to be Jupyter Notebook. So that's like the environment, and it's also web-based. If you don't have this, or if you've not started installing this, you can use what we call the Colab, Google Colab. So just go to colab.google. Once you say open new notebook, it's just going to open a blank sheet for you, right? It's just going to open a blank sheet for you, and you can write any of your Python code. You can learn basic Python, how to do basic Python variables, tuples, lists, functions, and all of that. Once you're done with that, then you can now start going into Python libraries. So like now, if you open it, recent examples, I could just maybe cancel this and just say, just give me a new notebook. It's going to open a very blank sheet for me. What is happening? At times, it might want you to save in a particular place. Okay, I think this my account is a corporate. Let me switch to a personal. Let me switch to a personal. Let me switch to a personal account and see. Colab.google.com. So once you open your Anaconda, it opens in this kind of environment. So this is what it looks like. So it opens something like this once you open Jupyter Notebook. So the idea is that you open your Anaconda Navigator, you do something like this, Anaconda Navigator. Once you click on this, it opens like something like this. Then you click on Launch Notebook, it opens on your browser. Once it opens to your browser, the next thing you can do is that you can adjust, let's say go to desktop, right? You can now say maybe you want to create a new file, a new Python file. So if you open a new Python file, of course, from there, you can now start coding. So I want everybody to be able to do this before tomorrow, because tomorrow, take for instance, you just say 1 + 1, right? To run this code, you can click on run, or you can use Shift-Enter. If I click on run, it's going to tell me what the answer is. If I say 25, 35 minus 15 I do shift enter, it's also going to give me a reply. If I say, okay, X is equals to 5, right? And Y is equals to 10, enter. And I say, okay, X times Y, right? It's going to give me the answer. So from tomorrow, we'll start coding basic Python. Then once we're done with basic Python, right? So we're going to first learn basic Python, right? So once we're done with learning basic Python, we are now going to do Python libraries. So Python libraries are things like NumPy, things like that's numerical Python, because to do a lot of analysis, you know you're not using a software kind of like a drag and drop. Now you are doing everything yourself. So some basic mathematics is what we're going to go through. Then we have Matplotlib, or let's say pandas, right? So this is majorly for your exploratory data analysis. Then we have Matplotlib. Then this is basically, this is a mathematical plotting library. Then of course, we now have Seaborn. This also, these two are for visualization. Then once we're done with that, we now start learning machine learning. In machine learning, we could pick, let's say, linear regression, and let's say k-means. So that's going to be the approach for the entire training. So before tomorrow, I want everybody to make sure that you have your Anaconda running. Like I said, we can also use the Colab, right? Colab.google.com. You can also code within this environment and you're going to be fine. Now, all the codes we will need throughout our training is already available in the sheets I gave to you guys. So tomorrow, what we're going to do is that we're going to open them, we'll evaluate them, so that even before the class time, you can actually run this code yourself, you can test it. All the codes we need for numerical Python, for pandas, for Matplotlib, for Seaborn, for linear regression, for k-means, all the code are already prepared with the case studies, with the data set and everything. I've sent everything to you. So it's on the WhatsApp group. I'm also going to repost it. So it will be easier for us. Within 3-4 weeks, we can become very, very competent in analyzing data and also running some machine learning algorithms. Okay, that will be all for today's class. Tomorrow we'll start with basic Python. Who have a question, please?